force down here, what would happen? It would spin, wouldn't it? Yeah. But this seems a little bit strange because this force equals this force. So what happens when you have forces that are equal but in the opposite direction? When they add together, what do you get? They cancel, yeah. So the forces cancel, how come it's doing something? You know, like if you think about it, it might seem a little bit strange. So here's a force here, here's a force here. But they cancel, so that's the same as this. But this one does nothing, and this one spins. So what's going on here? Well, what's going on is we need to think of three types of forces, okay? There's forces left and right in the x direction, and they can cancel. And they are independent to these forces, right? I mean, does this affect this? No, they're independent. We said this before. So they're forces in the y direction. But there's another direction. And the other direction is this anti-clockwise and clockwise. So you actually have three directions here. X, Y, and then clockwise and anti-clockwise. There's three directions. So in this picture, yes, there's no X and the Y's cancel. So there's no Y. But the clockwise and the anti-clockwise don't cancel. Because this guy goes anti and this guy goes anti. So together they go anti. Okay. So anyways, we've talked a bit. It's rotating. So we have this expression called equilibrium. And equilibrium means this. It's not doing anything. It's balanced. Okay. This one is not an equilibrium because it's rotating. Okay. Equilibrium means everything is balanced. So an object's in equilibrium if the total force is zero. So what that means is the force to the left equals the force to the right. The force up equals the force down. And what's the last one? Yeah, the turning force clockwise equals the turning force anti-clockwise. If you have these three things, we say it's in equilibrium. Yeah? Do we know this word equilibrium? Is this a word you've done in chemistry yet?
I don't think so.
Not yet, okay. Got that? Yeah. Continue? Yeah. Okay. In fact, the last point is called the principle of moment. So this last rule here, clockwise equals anti-clockwise, principle of moments, more or less. Who could that be?
Hey.
Colin.
Right. Morning, guys.
Good news for them?
Well,
News for them.
could be bad news.
Could be bad news, okay.
Unfortunately, Lorraine's not in today, so you won't have chemistry this afternoon. We'll look at it again tomorrow and see if we can recover it tomorrow afternoon, because you're free at 3 o'clock and 4 o'clock. Okay, so you're free this afternoon. Is that good news?
So what you're saying is they get to go home early?
Or if they like, Cab 009 is free, so if you want to go there as a study group as well.
But we have to stay home later, stay later for tomorrow.
Possibly, yeah. We'll just have to review, make a decision tomorrow when, if the rain's in or not. Okay, but we'll make up the class another day. Okay. Sorry. Lorraine's not in this today.
Chemistry teacher.
Lorraine. Okay. So we'll review again tomorrow morning. If she's in, we'll look at running chemistry tomorrow afternoon for 2 hours from 3 o'clock.
Instead of today. They have 2 hours today?
Yes.
Today no chemistry class. Teacher's
No.
not in.
No chemistry.
No, we won't.
We won't have because we not did last week.
No, you're free this afternoon.
Okay.
Good, right?
Okay. Okay, but the same rooms are available if you want to go there to study.
I think they have lots of physics homework to be doing still, right? Yeah, so I'm sure there's something for them to do for sure.
Okay. All right.
Yeah.
Thanks, guys.
Good.
Thanks, Stephen. Thanks.
Okay, did you write that down? Yeah? Okay. Okay, so let me do this question, but what I would like you to do is to try and draw the picture. A 40-kilogram boy sits at the end of a seesaw. Do you know a seesaw? The children's toy goes up and down. And the seesaw is 100 kilograms. And his sister, 30 kilograms, she sits at the other end. Okay? And the pivot is in the middle. And the seesaw is not balanced because who's heavier? The boy is heavier. So what will happen? He'll go down and she'll go up. So the father must move the pivot somewhere so that it's now balanced. Now I just want you to draw the picture and I'll do it. Okay, so just try and draw the picture. Good, good, and just put the numbers in if you can. Yeah? Yeah? Will we have a look at it now? So, let's have a look here. Yeah, it's a 5 meter thing. Okay. No, sorry. What am I doing? Should make it purple. Okay, there's the seesaw. Alright. Should make her at least look like she's sitting on it. Alright. There now. And then we'll put him here. We give him a cap. There. Right. Now she is 30 kilograms, and what's he? 40, isn't it? 40 kilograms, and the seesaw is 100 kilograms, and its length, I think we said from here to here, that's 5 meters. Okay. Now here's the problem. If you put this in the middle, then he'll go down and she'll go up, and then that's the end of the story. So we want to try and make it balanced, because if it's balanced, then it could move a little bit, which is what you want. If the boy is too heavy, then she can't She can't make it move. So we need to move this. Now, should we move it to the left or should we move it to the right? Yeah, we kind of picture maybe it's somewhere here because he's heavier, okay? So what we'll do is we'll call this distance x, and what will this distance be? Oh no, be careful. Yeah, it's 5 meters, not 100 meter seesaw, yeah. 5 minus x for that distance, and this one here is x. Now let me draw in the forces. How many forces are there in this picture? How many forces? 2, 3. No. 4, yeah. Now, do you know what 4 they are?
The boy, the girl.
Say again?
The boy is 1 force.
Yeah, the boy's weight, isn't that one? So, what's his weight? 40 g. And what's the girl's weight? 30 g. Now, what's the other forces?
Seesaw.
Yeah, there's a weight here from the seesaw, isn't there? Of 100 g.
Is it kilograms?
Yeah, it's 100 kilograms, so that's 100 times 9.81. Yeah. So that's 100 g. But there's one more force I did not draw in my picture. Yeah, because all these forces are pointing down. I need at least one force pointing up. The reaction here at the pivot. Yeah? Now, by the way, what's this distance from here to here?
50? I mean, 2.5?
Yeah, 2.5 meters. Because a half of the 5, isn't it? You half 100, isn't that what you did? Yeah. Okay. So we want this to be balanced. So, is there any force going to the left? No. Is there any force pointing to the right? No. Is there any force going up? Yeah, what force is going up? So the first one, left and right, there's nothing. Second one, up and down. What's the force going up? Or. And what's the forces going down?
30 g and 40 g.
And 100 g. So, in other words, 170 g. But the third one is the most important one, because the third one will help us find the x, which is what we want. The clockwise equals the anti-clockwise. Okay? So let's look at each force one by one. And tell me, okay, actually before that, where's the turning point here? Here it is, here. Okay, so picture that as the turning point. This is like the center of the clock. The center of the clock. Okay? Does this 30g make you turn clockwise or anti-clockwise? Anti-clockwise. Because you're going around like this. Yeah? Okay, good. Now, this one. Whoops. Clockwise or anti-clockwise? Anti. This one, clockwise or anti-clockwise? Clockwise. Can you see? Because this one makes you turn that way. This one here makes you turn that way. Opposite. And lastly, the or. This one. Clockwise or anti-clockwise? What do you think, Siva? Yeah. Why not? Yeah, cross the pivot, so forget about it. Okay? Now, let's calculate the total turning force clockwise. What's the formula for turning force? Force by distance. Okay, so let's start with the clockwise. What's the force? It's 40g. Yeah? Okay, and what's the distance from the force to the turning point? What's the distance? What do you think? Do you know, Kim? Go on, I think you might know. Maybe it's x? That's the distance for the first one? Yeah? Okay, let's look at the anti-clockwise. So let's do this one here first. The girl. What's her force? 30G. And what's the distance from her to the turning point? Very good, 5 minus x. Okay? Plus the 100G, and what's this distance here? You can see what that distance is. That's a little bit hard. That's it, yeah. It's 2.5 minus x, because here to here is 2.5, and here to here is x. So this one is 2.5 minus x. Right. Can you see I can solve this to get x now? What's in common to everything? What can we cancel here? There's something g. So we can cancel out the g, okay? So let me just scroll down a little bit here. So this would be 40x equals 150 minus 30x plus 250, yeah, minus 100x. Now, can you find x? Of course, that's easy peasy, isn't it? Let me just get it here. So 40 plus 70, 170 equals 150, 400. 400. So x is that, which is 40 over 17, which is 2.35. Thank you. Meters. Okay, so the father needs to do this. He needs to put it here, where this side is 2.35 meters, and this one is 2.65 meters, and now it's balanced. Yeah. Now remember at the start I said this lesson students find confusing because they don't like the picture. They don't like the picture. Okay. So do your best to write this down. It's a typical exam question though.
Was the weight of 100 or 1000?
That was 100 kilograms. Yeah. Okay. Got that? Not yet. Kim, you wrote this down? Yeah. Are we just waiting for George and Matt? I think I might need to push on a little bit because I have another example to do. Which part are you writing now? Did you write the maths? Oh, and yeah. How much have you got there, Matt? Okay, alright. Once you're finished, then maybe George could copy off of you. We have another example to do. So this one here, this one's called a single support because the seesaw has just one point that's holding it up. Okay. The next one I want to do is a double support, which is like maybe you have something here, and it's hanging like a bridge, you know, something like this. Okay, continue. Yeah, I have two more examples to do. Okay. A 100 gram meter stick is held by two strings. Okay, so I'll draw this for you. So this is 100 grams and it's 1 meter long. It's a meter stick. The first string is at 25 and the second is at 90. So, you know, you've got 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 centimeters. So the first string is at 25 and then the second string is at 90. Okay, and my question is, what is the tensions in the string? So there's a force here, and there's a force here, and of course 10, 20, 30, 40, 50, there's a force here of 0.1 G. And my question is, what's the T and what's the S? Okay, we got the picture, we understand the question? So my first question is there any forces left and right? No. Is there forces up and down? Yeah. What's the up force here? T and S. And the down force? 0.1 G. Now, can you find T and S here? No. What's the problem? Well, two unknowns and one equation. Okay, let's look at clockwise and anti-clockwise now. Where's the turning point? Where's the turning point? Okay, you're saying the middle? Anywhere else, could we? Anyone agree or disagree with that? Oh, no. Not that extreme. There is a turning point, yeah. No other opinions? You're all happy to go with the middle? Why not? Okay, well the thing is, there is a turning point, but in fact, you can put the turning point anywhere you want, and you'll get the right answer, okay? So if you want to put the turning point here, you can. If you want to put the turning point here, you can. If you want to put the turning point here, you can. Now this is where I'll choose to put the turning point. I'll choose to put the turning point here. Now you might say, well, why can I move it? Well, it doesn't really matter, because if it's not turning, then you can say it's balanced at any turning point. So it doesn't really matter. Okay, so if this is the turning point, is this force clockwise or anti-clockwise?
Clockwise.
Clockwise, and this one? Anti-clockwise. And this one? Yeah. Now it's nothing. Now can you see why? That's why I chose this turning point. Why did I choose this? So to make this one gone. Okay. So the first one, what's the force for the first one? It's 0.1 G. And what's the distance? What's this distance? Sorry, I didn't mark them off. These are supposed to be at. This is supposed to be at 25 centimeters, and this one's supposed to be at 90 centimeters. Okay, so what's the distance here to here? 25 centimeters, yeah? Okay, and that should equal this turning force, which is S. And what's the distance from here all the way to here? 65. Is it 90 minus 25, yeah? 65, okay. So that's 0.65. because that's the distance from here to the turning point. Because that's 25, and there is 90, so there's 65, yeah? Okay, can we get S? We can. We can say S equals 0.65. What am I doing? Sorry. S equals 0.1 times 9.81 times 0.25 over 0.65. Okay, what's that, please? 0.1, 9.81, 0.25, and 0.65.
$0.377.
0.377 newtons.
Yeah.
Now, can you get the T?
Yeah.
Yeah, you just put this answer back into this one. So you get T equals 0.981 minus 0.377. So then T would equal, so that answer was S. And what's T now? What's that, please?
$0.604.
0.604. Yeah, newtons. So there's my answer there. So it kind of makes sense that the T is bigger, doesn't it? Because this one is nearer to it. So it feels like this one should have more force in it than the S, which is further away. You know, if you could imagine the two strings, this T one here, it should have more force in it if this one is nearer to it. The S should have less. Yeah, okay. Still don't like it?
It's better than the last one.
The projectiles or
No, like the previous question.
do you think so? Or is it just because you've seen two now?
No, I just find this simpler.
Okay. Is it because of the X in the last one?
Kind of.
All right. We got that? Got that? Yeah, continue. Well, let me see what the next one was. This one's the same as the last one. Instead, all I did was in this one was I just made the story like this. So he's lifting up the weights. So there's a weight here and there's a weight here, but it's the same as the string with the meter stick. So I don't think I really need to do this one because I actually want you to start trying to do them. Yeah, because it's only like 5 minutes left. I want you to try one before you go. Yeah. I think you should try question 3 first because it's like the example I just did. I think if you got number 3 done before you go home, that would be good. Yeah, this one.